Right, this is a 2014 exam, question 3. You can pause here and read the question if you haven't already tried it. So let's think about this. A is the amount owed. Here's our variables here, and W is the amount of weeks. So 0 weeks he owes $4.50. After 1 week, paying off $15, it'll be $4.35. Paying off another $15, and so on, subtracting 15 each week. Right, now we're asked to graph it only for the first 5 weeks. Total amount still to pay, so starting at $4.50. Now we need to check the scale here. So 420, 430, 440, 450. So we're going up in tens. The scale is in tens. If we're paying off $15, then I'll need for the next week, if we go down 1.5 squares would be 15, and down another 1.5 squares for 15. Carry on with that up until 5 weeks, which is there. We're asked for the equation. A equals, clearly it's 450 minus 15 times the number of weeks. So each week we're subtracting another $15. Now, the answer schedule for this from NZQA actually draw this as a step function. So for excellence, the discrete dots there would be merit. So at excellence level we need to be thinking about a step function for this. It's not clear in the question when during that week the person is paying it off, whether it's at the beginning of the week, the end of the week, or somewhere in the middle. So which makes it awkward to know which way to do the steps, but we'll assume that during that first week $4.50 is owed and the person pays it off at some stage during that week, so that the next week they owe $4.35, and at some stage during that week where they owe $4.35, the second week they'll pay off another 15, and so on and so on. Now normally with a step function you need to be really careful about open and closed dots at each end. The answer schedule doesn't specify them for this. It's obviously a hard enough question and the steps are so small that they haven't worried about the open and closed dots. The way we've assumed it is that by the very end of the week or the beginning of the next one, the amount of money they owe is less. So at the beginning of the second week there, after 1 week, beginning of the second week, they now owe $4.35. And so in my case I would have the open circles that end. But like I say, the answer schedule doesn't want you to specify that because it's obviously difficult enough. Okay, so next question, you can pause and read this. This time he wants to pay it all off by 25 weeks. And to do that he's going to begin repaying $20 a week so that it's exactly paid off in 25 weeks. We're asked to add that to our graph, and just reading a little bit ahead, after how many weeks did he start paying $20 a week? So going back to our graph, the easiest way I find is to go down to the 25. We want it to be 0, and we're paying $20 a week before that. Now $20 is 2 squares, so going back up by 2 squares each week. What we want to do is keep going with the $15. Make sure we've got that right, 1.5 squares until the 2 combine. Now if I go back up 20 from there, that's not going to reach. So if we go back up 20 from here, that reaches, so putting that dot there. So here is where we're going to change. So this is the amount owed for that week, and during this week here from 10 to 11, which is the 10th week, during that 10th week we're going to pay off the $20, that's right on there, pay off the $20 instead of the 15. In the 10th week, counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, first week, second week, third week, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th. It's actually the 11th week. Going from 10 to 11 is the 11th week we're paying it off. Right, so back to here. After how many weeks? So after 10 weeks, i.e. the 11th week. Equation for that graph. Probably easiest if we use some points. Now we definitely know it goes through 25.0, and actually it will be $20 working backwards. If you go back to the graph, you'll see it goes through the point 25.0 and then back 20, so that's the point 24.20, and then 23 and 40. So I've got my 3 points. We go into stat on the calculator. Using stat, it's a linear graph. Even though we've drawn it as a step function, we'll choose linear on the calculator because it's an approximately straight line with the same payments, giving us an equation of A equals minus 20 W plus 500. The minus 20 sounds good because that's the gradient. We want this for W greater than or equal to 10. And you can just check whether we actually, what you get when W equals 10. Minus 20 times 10 is minus 200 plus 500. Gives me a total of 300, and the graph does go through the point 10, 300. Right, last question. We're asked to give the equation of the graph below. I can see it's exponential. It's an exponential growth curve. I can see that it's actually been dropped down and that it's levelling off to a value of minus 3. Exponentials have asymptotic nature. We call it asymptotic nature, where they level off towards a number. So the general equation for an exponential is y equals a to the x, and in this case it would be minus 3, because exponentials usually level off to the x-axis. This one has dropped down 3, so we need to minus 3. Now every graph has a table of points associated with it. If we try and, I can see that it goes through 0 and minus 1. Might be helpful to just do some points in order. Negative 1 and negative 2. 1 and 1. 2 goes through 5. Right, so looking at the differences and dividing up. 5 minutes? Dividing up. 2 divided by 1 is 2. 4 divided by 2 is 2. So I can see that this has to do with powers of 2. Right, so now we're dealing with y equals 2 to the x minus 3 as my initial choice. Working this out for a couple of values, when x equals 1, we would get y equals 2 to the 1 is 2 minus 3 is minus 1. Whoops. Minus 1. So it goes through the point 1 and minus 1, which is not quite right. Ours went through 0 and minus 1. When x equals 2, y equals 2 squared minus 3. 2 2s are 4 minus 3 is 1, so I'm going through 2 and 1, whereas we went through 1 and 1. So let's try playing around with this power here. When x equals 1, to get the minus 1, if we add 3, minus 1 plus 3 is 2, so I want 2 to the power of something that gives me 2. We want it to equal, when it goes through 1, we want it to equal 1 actually. We want that to equal 1. So if we just add 3 to both sides, 1 plus 3 is 4. 2 to the power of something would give me 4, then x is 2. So instead of being at 2 to the 1, I want it to be 2 to the 2. So I want to add 1 to x. Now that's quite complicated, and you might just need to play around and choose either x plus 1 or x minus 1. In this case, x plus 1 seems to work, and we'll just check. Go back over here, I can just erase. So x equals 1, substituting it into the power here, 1 plus 1 is 2. 2 squared is 4 minus 3 is 1. Now is that what I want? 1, 1. Yes, I do. Substituting 2 into the power, 2 plus 1 is 3. 2 times 2 is 4 times 2 is 8, minus 3 is 5. Is that what I want? Yes, I do. So I'm happy with that there. We could have tried 2 to the x minus 1 as well. This is clearly a sideways shift, and it's always a bit harder to spot in your graph.